In last video we calculate the moment magnifier. Now in this video we are estimating the reinforcing steels. So design stress resultant for the column sections are, so if I want to know the maximum moment, that is the moment magnifier times by M2 stars 1.41 moment magnifier. I can show it to you. In the last video we look at the moment magnifier 1.41 and M2 stars. If you go back to the definition of M2 stars, where it is a maximum moments subjected in the columns end. So we have 270 kilonewton meters and you have 360 kilonewton meters. We are taking 360 kilonewton meters. Where is given? I think in our previous calculations we look at that moment ratio. I can show it to you in the few pages back, where we look at that moment ratio. Here you go. In the clause number 10.3.1 we will look at that M1 star over M2 star, which is the smaller over larger design bending moment. We look at that ratio in the previous videos, but I'm just pointing it out again. So M2 star is the larger design bending moment that we just look at here. So that's simplification give 508 kilonewton meters, and N star is 2000 kilonewtons. Design axial force is 2000 kilonewtons, that is given here, and we are designing this C column, so therefore we are taking 2000 kilonewtons. From the figure, reinforcement ratio P equal to 0.112. Which figures I am talking about? The figures that I am talking about is the one that we use here. So in here 508 kilonewtons, and for 2000, so if I have a 2000s here, if I draw the line here and 508, about this, between these two line 400 and 500, it would be 500. So it's in the middle of 0.01 and 0.02. so we have about 0.0112 is about in between. So that's ratio are taken at this particular point here, 2000s and 508. So that's this point here. So that is the reinforcement ratio 0.012. By the way, this one 0.01, that the minimum one, that standard also has given us the value. If you remember, in the previous video we take the reinforcement ratio minimum 0.01. Now that minimum reinforcement ratio 0.01 is coming from this clause. I can show it to you here. Here you go. Limitation of longitudinal stress should not be less than 0.01. So that is the reinforcement ratio equal to minimum 0.01. So that is coming from that standards. I can show you in our examples where we look at the row minimums. That's row minimums. Just finding it. There you go. There in the previous videos we take row minimum reinforcement ratio 0.01. So that's I take it here. So we take this row equal to 0.012. This is sufficiently close to the value of row 0.01 that we take it just now. That is very close to row, because if you remember that we have assumptions saying that need to be checked later, so we are checking it right now that it should be around 0.01. we use that 0.01 in the calculation of these 5 MC buckling loads, moment magnifier, delta B and delta C. If this has a big difference, we need to do the iteration and go over again this process and make sure that the assumed value is close to that value. Now that's good. So we validate the assumptions. Now the total amount of longitudinal reinforcement required is therefore, so area of the steel is equal to reinforcement ratio times the gross area. I think I can put this one as a gross area. Now where is it coming from? So if you go back here, in that clause that they say that 0.0 the reinforcement ratio times gross area, that is the longitudinal steel. So that's longitudinal steel. I just put AS equal to P times the gross area, 0.012 that we just estimated from that figures, times by 400 times by 600. Now 400 and 600, that is coming from our cross sections. Our cross section is 400 millimeter by 600 millimeters. So that is here, that gives me 2880 millimeter square. So if it is 2800 millimeter squares, we need 3 N bars. So if you are just N 20 bars, we are using N20 bars. So if I have a pi by 4 times 28 square times by 3, so you have about 1847 times by 2, so we around 3694. Because in our this Rio data tables, if you go back to the Rio data tables here, we need to find N28. So N28, and we don't have 2880, so we don't have 2800 around this 3080, but we can't provide 5 bars. We need to provide the even bar 6 bars, because 3 at the top, 3 at the bottom. So we can take 3696 millimeter square, and we provide the 6 and 12 bars. So that you can say 3696. So we can write provide 3696 millimeter square. That's the reinforcement ratio for the 6 and 28 bars. Now reinforcement detailing for the columns fitment reinforcement. R10 fitments are required at the spacing not exceeding lesser of DC and 10 dB. Where is coming from? That is coming from this clause here. That clause is clause 10.7.4.3. It says that spacing of the fitments should not be exceeding smaller of this one. So minimum of DC 15 dB. DC is a smaller diameter of your smaller dimension of your cross section. So our cross section is 400 and 600, so we take it 400, smaller dimensions, 400 times 15. So we are using N28 bars. We are using N28, so times 28, so it's give me this, the minimum value of 400 millimeter square. So the spacing that we're going to provide is a 400 millimeter square. Thus the R fitments are spaced at 400 millimeter centers. So we have a longitudinal reinforcement is shown in the figures. So every fitments we will have these R10 fitments at 400 centers. Now this spacing that you are showing is a 10, 15 or dB. Thus I just explain it here. So that is the longitudinal spacings, right? So that spacings that you are seeing it here. Now there is a reinforcement detailings as well that I just put it here. That if your reinforcement, longitudinal reinforcement is less than 150, the space between the longitudinal reinforcement is less than 150, where is it written in the clause 10.4.1 in here is written here, saying that you should have about 150 millimeters. Then you no need to provide this internal fitments. External fitments is enough. But if you have this longitudinal reinforcement is greater than 150 millimeters, you need to provide this internal ties. That's happen in our in our examples where you have this longitudinal reinforcement are greater than 150 millimeters. So here we have a greater than 150 millimeters. So therefore we provide this internal ties. So that's the examples, the reinforcement detailing and calculating the area of longitudinal reinforcement in our column example. Thank you.